Hello and welcome to Technical Utkranti, and today we are going to see the sixth question on binary search, which involves finding the median of two sorted arrays combined. But before that, let's have a look at the thought for the day. Alright, so this is the fifth question. Sorry if I had said sixth question previously. This is the fifth question, and let's move on understanding the question. So you're given two arrays, nums1 and nums2. Both of them are sorted like this, and you need to find the median of both the arrays combined. So if both the arrays are combined, it would be 0, 1, 2, 3, 4, 5, 6, 7, right? And since the number of elements are odd, there would be two middle elements, which would be 3 and 4, and the average of the 3 and 4 would be the median. But first of all, have a look at the naive approach of solving this question. So we have two arrays over here, and how are we going to sort it into one single array, which would look like 0, 1, 2, 3, 4, 5, 6, 7. So in the naive approach, the way we do sorting in merge sort, we keep one pointer over here and one pointer over at the starting of both the arrays, and whichever array element is smaller, that element we put in a new array and increment the pointer over here. Again, we compare both of them. This is a small, this goes here, and this is incremented to come over here. And similarly, now this is small. Similarly, the entire array would get filled like this. So this filling is O of n time complexity, and middle element would be 2 and their average would be 3.5. So that is how basically the naive approach works. But now we'll solve it using binary search. How are we going to do it? So we'll be applying the partition basically. So we know that in the final array, uh, we can divide it into two halves. Okay, and this will be a smaller half. This will be the half having larger elements. So some of these elements in the smaller half will be coming from this array, and some of the elements in the smaller half would be coming from this array, right? So what we do is we create a partition over here, all right, in order to calculate half this half array, okay? So if this is of length n1 and this is of length n2, and if we get cut one number of elements from the first array, then we need to have n1 plus n2 by 2 minus cut 1 elements from the second array. So cut 2 will be this, all right? Okay, okay. So in our case, n1 is 4, n2 is 4, n1 plus n2 by 2 is 4, all right? So cut 2 becomes equal to 4 minus cut 1, okay? Now we apply binary search on the smaller array. All right. Okay. Low will be 0. H will be equal to n1, which is 4. And mid value comes out to be 2. So 0 is here, 1 is here, 2 is here. So here we create a partition. And if cut 1 is 2, cut 1 is 2, then cut 2 becomes 2. Right. So cut 2 becomes 2. Cut 2 is also here. All right. So this is L1, this is L2, this is R1, this is R2. Why such nomenclature? Because all of these would be the left side of this complete array, and all of these elements would be forming the right side of the complete array. All right. Now, now we know that each element on left half should be less than or equal to each element on the right half. All right. So we need to ensure that L1 is less than R1 and R2, and L2 should be less than R1 and R2. But we already know that this is in non-decreasing order. So L1 will be less than R1, less than equal to R1, and L2 will be less than equal to R2. So what we need to just ensure is L1 should be less than equal to R2, L1 should be less than equal to R2, and L2 should be less than equal to R1. If these conditions are satisfied, our cuts are correct. All right. So now we have applied this mid equal to 2 and we need to see whether our cuts are proper or not. So 2 is less than 5 and 3 is less than 4. So our cuts are proper now. All right. Then we see that this becomes left half and this becomes right half, right? Now, now we'll take the highest element of this array and the highest and the smallest element of this array and take their average. So either this is going to be the highest element on the left side or this is going to be the highest element, because these are all non-decreasing order. So either this or this is going to be the highest element in the left half. So what we'll do, max of L1 comma L2 plus, these are going to be the minimum elements of the respective right halves, right? So either this is going to be the minimum or this is going to be the minimum. So what we'll do is we'll take min of R1 comma R2. Once this is done, we'll take its average. So that is how we are going to calculate the median in case the number of elements are even. In case of odd, we'll ensure that the left half of the array that we are making will have one extra element in case of odd, and that element is going to be the median. So more explanation now we'll see with the help of the algorithm itself. So here is the algorithm. What we are doing, first of all, we are seeing that whichever array is smaller, that is the one on which we'll be applying binary search to improve our time complexity. Now, we just find the length of both the arrays and make L equals to 0 and H equal to length of the smaller array. All right. Now the binary search starts. We get cut1 as L plus H by 2. Then cut2 would be, as we have illustrated, N1 plus N2 by 2. But in case of odd, it would be N1 plus N2 plus 1 by 2. But this formula works equally well for even number of elements also. So for example, if N1 is 4 and N2 is also 4, then 4 plus 4 by 2 is 4. But 4 plus 4 plus 1, which is 9 by 2, is also 4. So this formula is for odd number of elements, but it works equally good for even number of elements. All right. Now, what we see, if cut1 is 0, so if there are no elements on the left side of cut1, then we basically assign very negative value to left one element, because the comparison of left one with R2 is not even required because there is no left one. So that is why we assigned a very negative value to left one, right? And if cut one is greater than 0, then we find the left one element, L1 element. Similarly, for cut 2, we find left 2 like this, all right? And then we find R1 with this formula and R2 with this formula. Now, we see if left 1 is less than right and left 2 is less than right 1. So L1 less than R2 and L2 less than R1. Then for case of even number of elements, we use this formula. For total number of elements being odd, we use this formula. If that is not the case, then we see if left 1 is greater than right 2. So if this is greater than this, then we need to move the cut towards the left, right? That is how we get L1 small, right? So in our case, that is not the case, but if L1 is not less than R2, so if L1 is greater than R2, then we need to reduce L1, right? We need to reduce L1. In order to reduce L1, we need to move the cut towards left. what we do when we have to move the cut 1 towards left, we make high as a smaller values. High we'll make cut 1 minus 1. And if we see that left 2 is greater than right 1. If left 2 is greater than right 1, then we need, so again going back, if we see that left 2, which is supposed to be less than R1, is greater than R1. Okay, so we need to reduce this value. And if we need to reduce this value, we need to move cut 2 here, right? And in order to move cut 2 here, we need to move cut 1 this side. And in order to move cut 1 this side, we need to make the low pointer, L pointer, to be bigger. So what we do, L is equal to, we make L equals to cut 1 plus 1. I hope this algorithm was clear to you. And this algorithm finally, if it converges on this condition, then we have a solution. If it doesn't, then we return 0. So let's submit it and see if we have a solution. Yes, our solution is accepted. So I hope you understood the question and the approach which I illustrated during the algorithm explanation and the code. If you did, please give it a thumbs up and subscribe to my channel. Thank you. Bye bye.